Even before we consider the question of lost or duplicated packets, let's consider the question of corrupted packets. Like, what if the receiving host receives a packet just after the sending host sends one, but the data that it receives doesn't match the data that was sent in this unreliable data transfer at the sending host? There are different ways we might imagine addressing this. For example, we might have the sending host send the same packet twice, and then the receiving host needs to make sure that it gets exactly the same data twice. That would prevent many kinds of errors because a random error in the network is unlikely to produce the same random result twice. But that would also mean that we're doubling the amount of data we're sending, which is not great. So we would like a way for the receiving host to know that there's some evidence that the packet it receives is what was intended without having to duplicate or send a lot of extra data. The idea that we're going to use here is called a checksum, and this is similar to the idea that if you're at a store and you tell the clerk, I'd like an apple, 2 bananas, and 3 cherries, and the clerk says, okay, here's an apple, 2 bananas, and 2 cherries, even without looking at all of the information, you would get 5 things back, even though you asked for 6 things. And so you would know, not only is that not the right result, there would be a simple way to say, look, I asked you for 6 things, you only gave me 5. So that's the idea we're going to use. We're going to send our request with a counter that says something about here is how much I asked for. Instead of talking about numbers of fruit, it'll just be here is like the addition of all the bytes that I meant to send you. And then that is like on the receiver side saying, okay, I think I got your message. 1 apple, 2 bananas, 2 cherries, which is 6. Oh, wait, 6 is not the addition here, or sum total does not match the content of all the bytes that was sent, and so the receiver will know that something has gone wrong. If we just add up all the bytes that we send, that's about the same information almost as the bytes that we sent. So what we do with checksums is we do that addition, but we only keep the low bits of the sum. We basically only pay attention to the last few digits of the total sum. And with addition, that's a thing you can do as you keep a running total. You only have to keep the low bits of that running total. So it makes it efficient. It makes the amount of extra information we have to send quite small, and it turns out to catch a lot of problems. We're not trying to catch problems where people construct malicious messages that end up with the right number even though they change the content. We'll have to come back to that in the cryptography part of the course.